Today's session, we are going to see different kinds of methods that are being used in building part-of-speech tagging. So, in the last session, we have seen there are multiple methods to build part-of-speech tagging. One is on rule-based part-of-speech tagging and transformation-based part-of-speech tagging, statistical-based POS, and this statistical is also called as stochastic or probabilistic way of building the POS tagging. And there are multiple methods here: hidden Markov models, maximum entropy models, and conditional random fields are most commonly used stochastic approaches while building the POS tagging. And other than that, there are multiple machine learning algorithms that are popularly used in building POS tagging. It includes neural network based approaches, deep learning based approaches, and the large language models like BERT are all being used to fine tune to build the POS tagging for languages. And apart from that, some hybrid methods can also be used in building the part-of-speech tagging. So, it is a combination of rule-based, statistical-based and machine learning approaches. So, for example, integrating the conditional random field, which is the statistical approach, with the neural network feature, we can build the hybrid way of building the POS tagging. Okay, let's go one by one. Let's start with rule-based approach. So, rule-based is nothing but typically like list of words with their possible part-of-speech tagging. So, we will typically start with the dictionary of words and their possible tags. So, and assign all the possible tags to the words that are being found in the dictionary. And we write rules by hand to selectively remove the tags. Then stop when each word has exactly one tag, then we are able to stop that particular point and try to see that that particular tag goes along with the other words in the sentence. So, for example, she promised to back the bill. Now, the possible tags for all the words in these sentences are she as a pronoun, promised, it can be a verb in past tense or it can be a verb in participle form, and to can be a preposition or to can be an infinitive marker followed by a verb, and back can be a verb, JJ can be it can be an adjective, it can be an adverb or a noun, and similarly bill can be a noun or a verb. Now, the situation shows that there is an ambiguity of tags that are associated with words in this sentence. Now, how to select one of the best tags in this given context? Now, since it is being tagged with one particular tag, PRP would be the best tag, and promised is being selected as verb with the past tense because the preceded one is a pronoun, because the participle form requires the preceding one as an auxiliary or a modal verb. So, in this context, the small context window shows that it is being selected with VBD because of the given tag PRP in the previous case. Similarly, to is being selected looking at the next word prediction. So, the next word is, let us say, predicted as VB, or this particular word is predicted as TO. So, that is why it is these two of them are disambiguated with the category called, let us say, infinitive and the verb phrase. And the is a determiner, and since the is a determiner, it will automatically selects NN as the tag, not VB as the tag. Right. So, what it does is it utilizes the dictionary to assign each word initially to get the potential part-of-speech tagging, and second stage it applies lot of handwritten rules to disambiguate them so that we are narrowing down into a single part-of-speech to each word. So, one of the best example for rule-based approach is EngCG ENGTWOL tagger. It is a real rule-based tagger designed for English and other languages. So, it has a richer dictionary which includes the morphological as well as syntactic feature, especially subcategorization frames that are nothing but verbs can have some kind of frames. So, the subcategorization frames are nothing but verbs of one type require a compulsory object. For example, when you say she saw a man. So, now the verb see requires an object. She saw. Whom he saw? He saw a man, right? So this is an object, which is a very important thing. But when the sentence like she runs, it doesn't require an object, right? So this kind of verb might not require, it's a minus object kind of verb, and whereas this kind of verb are plus object kind of verb. So technically we call this kind of verbs are transitive verbs, whereas this kind of verbs are intransitive verbs. So looking at their capability of taking arguments, especially either it can take an object or it can take a location or it can take any other arguments that are important to understand the complete sentence, are being taken forward in the dictionary form. And now we use two levels of morphological analysis on input and returns all the possible POS. So again, negative constraints are the most important thing. Almost around like more than 3,744 negative constraints are used to incorrect POS tagging, so that the correct POS tagging can be captured. So the pros and cons of this particular method is it's easy to interpret and also easy to understand, because the rules are there, and there is a negative rule says that okay, there is a infinitive marker, it cannot be followed by a noun, it should be followed by a verb base, right? So but customization is also very easy, because it can tailor to a particular language requirement, and here we don't need any training data. So what we need is a dictionary and a rich information about each words and their possible POS tagging without any context. So the disadvantages of this particular method is it may miss out some kind of complex linguistic phenomena, because since it's based on the dictionary, the interdependency between two words may not be always at the similar place. It can be at any length in the sentence. And the scalability is another important thing, because it's very difficult to maintain large database with large number of rules. When the rule increases, again the scalability is an issue, and it is less accurate when you compare it with statistical or machine learning method, but it is one of the initial method people have started working on building the rule based POS tagging. And the second method that has been popularly again used is transformation based tagging. So it is introduced by Eric Brill in 1992. So Brill tagger is one of the very well known successful tagger in languages. So this is based on the transformation based tagging. So the objective of this particular thing, use still a rule based approach, but use it iteratively so that we can go for different kind of transformation and finally select the best tag from the given tag sets. So the key components is, it starts with an initial stage where we assign a naive label to each of the word, whatever it is, there will be a label that is being attached to a particular word. And there are a lot of transformations. That transformation helps us in correcting errors in the initial stage, looking at the context. Unlike the rule-based tagger, where it provides all possible tags and try to select the best one of them in the subsequent stages. Whereas here in this particular stage, each word is being assigned with one tag and transform it according to the context. So here identifying error in the current stage is coming through the learning of that particular thing, and it creates transformation rule to correct these errors, and we keep applying the rule and iterate this process until we are finally coming up with a convincing structure or the kind of co-occurrence of the tags that are allowed in a language. So the final output is a sequence of rules that are applied to improve the tagging accuracy. So this transformation based learning can be compared to a painting analogy. Let's say we have a picture, and the picture has to be painted according to the requirement of whatever color code that is being accepted naturally. So for example, this is a picture where there is a sun and there is a sky and there is a house with a window and doors and there is a meadow place, right? So now apply all single color to all places. Then look at the context. Now let's say blue is being applied to everywhere in this particular picture, and looking at the downside, so this is the place for meadow, then this particular place is always been associated with the green color. Now convert the blue into green. Similarly, the roof of the house and the door of the house, let's say it's been associated with the brown, converted it into brown, and the house is been converted into, let's say, red. Then finally the sun is being converted into yellow, right? So this is a kind of transformation that is happening stage by stage, tags that are being associated in the sequence, in the nearby sequence. So now, what is this transformation rules? This helps us changing a rule, that means a particular word with the tag A into B when there is an internal evidence. Especially morphology plays an important role. Looking at the word's inflection most of the time helps us in identifying whether it can be a noun or a verb or any other category. Let's say sometimes the morphology itself is ambiguous, like in English, books can be a noun with a plural marker, or it can be a verb in the present tense with some kind of agreement marker. So then go for the context. The context is one or more of the preceding or following word with a specific tag, and one or more of the preceding and following word, especially that specific word. One is the tag, another one is the word, and the third one is a certain form that is being associated with that word. So all the form, word, tag are being used in identifying the current word's tag. So now again here order of rules are very important. Changing the order changes the whole complexity in the identification of proper POS. So again it is a cascading effect, because one rule is gone into the another set of rule. So it's all interdependent to each other. So rules can change a correct tag into an incorrect tag. So another rule might be required to correct that mistake. So it is well often known that first sometimes corrected tag will be incorrected, then again incorrected tag will be again corrected. So if a word is, let's say, currently tagged as noun and it has a suffix with the length of 1 with the character S. Now this changes helps us in converting into NNS, that is a plural form of the noun. Now the rule 2 helps us in identifying, let's say there is a word ends with ly. So easily it can be change its tag to RB, an adverb. And change of the particular category like VBN, that's a participle form, into the past form if the previous word is a noun, right? So for example, the sentence like the boy played versus the boy has played. So now both can be played, but in this context it is preceded by a noun, whereas it is preceded by a modal verb. So now this is a VBN, whereas this played is a VBD. So VBD is selected because the previous word is tagged as NN. And now change the VBD again into VBN if the previous word is by. For example, the apple was eaten by me, right? So now the eaten, it can be VBD or it can be VBN in the initial position, but this by will help us say, selecting VBN instead of VBD. So this kind of changes will help us in identifying the correct tag in a given sentence. So for example, again, let's take 3 sentences here. In all the 3 sentences there is a verb with a particular tag, okay, and now let's say in one case it is a VBN, in another case it is a VBD, in another case it is a VBN. You see the first sentence is a very simple sentence where Booth killed Abraham Lincoln. So again the preceding one is an NP or an NN, I could even call it as an NN. So now VBN is not the right tag, let's say. And here in this case, was shot by Booth. Now there is an auxiliary that is preceded, and here there is no auxiliary, but he witnessed Lincoln killed by Booth, but it is not preceded by an auxiliary verb. Now how we can identify the correct tag in the context? Now, how to now convert VBN into VBD? Now the previous tag will help us. Okay, there is an NP or NN. So convert this VBN into VBD. So now let's say VBN is changed into VBD in both the cases. Of course, it should not be changed, it should be VBN, because only if your previous tag is NP. Now the third thing, in this case VBD is fine, but in this case it cannot be VBD, right? So there is an NN, but though it is an NN, this is a passive construction, so the verb should be in the participle form. So now look at the next word. Okay, there is a next word like by. So using this one, again convert into VB, this VBD into VBN. So now it started with VBN and changed into VBD, again it is being converted into VBN. So this is a kind of transformation happened on the particular category. Now, so actually transformation based tagging, especially in the Brill tagging, he used both rule based approach and some kind of statistical approach. Stochastic is nothing but a statistical approach. So in this case, it uses the rules to specify the tags in a certain environment, and it utilized a tagged corpus to find out the best performing rules, especially looking at the probability and finding out the best tag in the given context. So the key feature here is the rules are learned from data instead of it is being hard coded by the expert there. So the input is tagged corpus. So it is used as a trained corpus where the rules are being learned initially, and the dictionary which contains the most frequent tags associated with words. Okay. So the initial step is it starts with a method and assigns the primary tag to each word, and in rule 2 it applies iteratively the transformation rules so that it refines the initial stage, and this transformation rules will have conditions, actions and etc. And the third step is after each rule is applied, the tagging accuracy is evaluated, and the rule that most improves accuracy is retained. So it is a kind of iteration process. So it is repeated until the criterion is met. So that means there is no further improvement that is possible from the rule set. The final output is we are getting the sequence of ordered transformation rules applied to the data, so that we are trying to get the accurate POS tags. So the same thing is being expressed here in the steps here. So label each word, then check for each of the transformation, select the word which has most frequent tag from the gold standard or from the corpus from where we have derived the rules, and retag the corpus, apply the rule again and again, and finally you get the thing that means this much percentage of correct word is being identified for this particular word, then stop the process. So the result is, of course, we are getting the POS tag to information. So for example, let's take the word like race. Race occurs in the brown corpus, let's say in the following probabilities. Probability of race as a noun is, let's say, 0.98, whereas the probability of verb as a race is 0.02. Now in this case, let's say he is expected to race tomorrow. Now the race occurs with the probability saying that okay, it is the highest probability race as a noun, so apply it to noun. Now again change that noun into VB, because look at the probability of this particular tag coming along with a noun in this particular kind of construction. So whenever the race in the singular form comes, there is a determiner that should come. So in this case there is no determiner, so 2 is followed by a word race, but the probability of 2 and race will be combined together will be more than the probability of 2, that means infinitive form followed by a noun. So now this particular thing is being applied, and finally we are changing that rule to select the verb instead of a noun. So now This is how transformation tagging helps. Now, the problem with the transformation tagging again is dependent on the rule, the quality of the rule. If the rule is not applied in a proper order, it will actually mess up the complete thing. So that's why the third approach is being most commonly used by people to build the POS tagging. That is called stochastic tagging. So it uses completely probabilistic method. So this method uses this statistical approach to predict the POS tagging. So for example, the likelihood of tag sequence and word tag pair, these two are being used to identify the current words tag set. So the key concept here is probability model. So it estimates the probability of sequence of tags given in a sequence of words. And training data is nothing but, this is the most important step here, we have to tag the corpus to estimate the probabilities. So the gold standard data is very much important to make sure that machine learns through the data now. And the tag sequence is actually determined or identified through the most likely sequence of tags for a given sequence of words. So now how to train this POS tagger? One is training the process. Training process is a very much important thing when we are working with a statistical approach. So it is trained rather than it is being written as a rule, or it is being transformed into one tag to another tag. So the corpus of tag data is being used to train the thing. So training involves learning tagging rules automatically from the data. So the training corpus, it can be a small or a big corpus, but it is hand tagged with POS tags so that the machine takes it as a reference and learns it through this reference and identifies the kind of probability of a particular word and its actually neighboring words. Now, are they need to use rules? Yes, they need to use the rules. They learn the rules using the tagging corpus. So rules are identified through the most likely sequences. So it is based on internal evidence, again the morphological features. It uses the contextual thing, there is an external evidence, and it uses also probabilities. It is nothing but the likelihood of the particular tag sequence in a given order. And here two types of probabilities are very important. One is individual word probabilities, which identifies how many times a word is being associated with a particular tag. And the second one is tag sequence probability. That means how many times a tag is being either followed or preceded by another tag in the given context. So now how to learn the individual word probability? So individual word probabilities are nothing but the probability that a given tag, that is T, is appropriate for the given word W is estimated through the training corpus. So it is nothing but it helps us in determining the likelihood of each possible tag of a word. So the formula is like the probability of a particular word in a given particular tag is nothing but the given tag T is appropriated for a given word W. So it is calculated as the frequency of that particular tag with that particular word divided by the frequency of that particular word. So this F of T, W is the frequency of the word W occurring with the tag T, and F of W is nothing but the total frequency of the word in the corpus. Now for example, let's take the word run. Let's say run occurs 4,800 times in the training corpus, in which 3,600 times it is occurring as a verb and 1,200 times it is occurring as a noun. Now the probability of run being as a verb is calculated through total number of occurrences of run, that is 4,800 times, and number of occurrences of run as a verb is 3,600 times. So the probability is 0.75. So run occurring in the context as verb is 0.75. Right. So it indicates that 75% of probability that the word run is used as a verb. Now, how is the sequence probability helps us? So, tag sequence probability is another important thing, where given a tag sequence like T1, T2 to Tn, it is appropriate for a given word, let's say W1, W2 to Wn, it is denoted as probability of word sequence 1 to Wn in a given tag set of T1, T2 to Tn respectively. So, it is this particular calculating thing will help us in understanding how complex the sequence of a given tag for a word in the sentence. So, it is used with a simplified chain rule like something like this. So, there is probability of a tag 1 and this probability of the tag 1 in the given context of T2 and this T1 and T2 in the context of T3. So, we are trying to recurrently identifying how each tags are being associated with another tag in a given context. So, this joint probability is decomposed into a product of conditional probabilities. So, this approach actually reduces complexity by breaking the problem into manageable parts. Now, the subsequence models for tag probability is again very important because using subsequences will help us in identifying the best probability of a particular word to the given tag. So, direct computation of full sequence of probabilities is complex because if we have a sentence with, let's say, 14 or 15 words, identifying each of the words probability with the previous combinations is really a complex thing. So, the simplified models uses only 2 to 3 tags, that is backtractable or a forward or a backward tractable, instead of going through the complete chain to the beginning of the word till the end of the word. So, for this bigram models are much useful. So, it uses the sequence of 2 tags. Now, the probability of a tag sequence 1 and 2 is nothing but the probability of tag 1 in the given context, how many times it's been occurring with the probability of tag 2. So, on the other hand, trigram model looks for the sequence of 3 tags. So, the probability of tag sequence T1, T2 and T3 is being calculated as the probability of tag 1 in the context of tag 2 and it is a kind of product, and again probability of tag 2 is in the context of tag 3. And n-gram model is being used whenever the language could not get the sequence in bigram or trigram method. So, it is generalized to sequence the n, it can be a 4 or 5 or a 6, whatever it may be. So, now the probability of tag sequence T1 to Tn is calculated as, let's say it starts with 2 because 2 is the most minimal way, it's a bigram model, and went to till the n number, and it's trying to identify each of the tags probability as a product. Now, the common models that are being used in using this kind of probability to build POS taggings are hidden Markov model. So, hidden Markov model is one sequence of model uses different kind of probability. One is transition probability and another one is an emission probability. Transition probability is how many time a tag is being transferred into another tag, or it's been traveled to another tag within the context, and emission probability is how many time a word is being associated with a particular tag. So, we will see in detail in the next slide about hidden Markov model. And maximum entropy model is another model. It again uses the probabilistic features, especially multiple features and constraints. We will see in the next slide again. Conditional random field is again CRF. This is a conditional probability of a tag to the given observed data. It is a more of deterministic approach. Given the data set, it is trying to create some kind of conditional information, then of trying to create a generalized understanding. So, it handles the dependencies between tags in a more flexible way. Okay, so let's again go to the next understanding on, we have built the POS model. Now, once the POS model is being built, how do we evaluate whether the model predicts the correct output or not? So, we need to understand what are the strategies that are being used in evaluating the POS tags. Tagging. POS tagging involves again measuring how well the system's output matches with the gold standard, that is nothing but human defined labels. So we'll explore here confusion matrix, accuracy, precision and recall, and F measure or FN score. So let's start with confusion matrix. So confusion matrix visualizes how a tagging system performs relative to the goal label. For example, there are 4 important things. If a tag is being given, how many times it is a true positive, that means correctly identified as positive case. That means the model also predicted a particular word with a particular category. Let's say John is predicted as a proper noun. Both model as well as the human annotated goal data predict in the similar way. So those contexts are true positives, and false positives are incorrectly identified as positive. Let's say John is incorrectly identified as a noun instead of a proper noun. So that is a context where it is it's a false positive. And true negatives are correctly identified, but it is identified with the negative class which is not there in the training corpus, let's say. And false negatives are incorrectly identified as negative. So how these things are used? Let's say system is giving us positive, but the gold, that means human thing, is also positive. They are true positives. Gold is actually negative, but the system identified it as a positive. Again, it is a false positive, whereas the goal did not say it is a negative word. Right? So system identified as a negative, but goal says it's a positive. They are false negatives. And system identifies something as like negative. Similarly, gold is also identified as negative. So these are all true negatives. Actually, they are negatives. But the problem comes only in these 2 stages where there is a difference between false positives and false negatives. Now, normally accuracy is being measured through overall correctness of the tagging system. So it identified all the cases, true positives, false positives, true negatives and false negative, and takes only the true cases where true positives and true negatives are being taken, and this can be identified. Now it is also sometimes misleading, because in cases of imbalance where there is lot of difference in the training or the testing set, where one class is much more frequent than the another, so the accuracy may show it in a different way. So that's why precision and recall can be utilized. So precision measures the accuracy of how many times positive prediction happen. So out of true positives and false positive, how many of them are true positives? Okay. So recall on the other hand measures actually the correctness of the truly identified positive instances. So it identifies true positives and false negatives, out of which how many are true positives. So both precision and recall are most important metrics, especially in the cases of unbalanced data sets. Now the same thing is being given in this slide. So gold standard labels and the system output labels are being used here, and we are trying to identify the past precision looking at only the true values, like even selecting the false values in the precision case, whereas in the recall stage it is only the the correctness of the system, how many times true positives and false negatives are being identified, out of which how many of them are true positives. Accuracy on the other hand looks at the overall performance of the system. Okay, so takes everything into the consideration and looks at how many times they are actually true. Okay. So now precision and recall gives a different kind of value. Now FN score, F measure combines these both values into single metric. So it is defined as, let's say, like f of b, like beta is nothing but 1 plus beta square into precision into recall divided by beta square into precision plus recall. Now let's say beta is always 1, it simplifies the FN score. So now the simplified FN score is nothing but 2 into precision, that means its beta is always 1, right? So 2 into precision into recall by precision plus recall. Now the F measure actually balances the precision and recall, whereas beta adjusting is importance of recall versus precision. So with this we are actually learnt about the POS tagging, different kind of methods in building POS tagging and how to evaluate the POS tagging. Thank you.